Alright, this lesson is coming from section 1.7 and the problems are on page 141. In this particular group, you need to open the book and look at the problem because they're word problems, so I'm not going to write out the entire problem. The first group of problems that we're looking at are going to be mixture problems. And what I have found helpful is to make a little chart. In this column, I put something that tells us how the types of things that are being mixed together are differentiated. Is it a percent of something that they have? Is it a cost per pound? What is it that makes one of those kinds different from the other? And then in this column, we're going to put the amount. And in this column, we're going to multiply those two together. So the first problem we're looking at is problem number 23, and it tells me in that problem that she wants to mix some Earl Grey tea, so I'm going to put EG for Earl Grey, and that it sells for $6 a pound. Well, that's what makes it different from the other kind, is that it sells for $6. So I'm going to put $6 per pound right here. And they want to mix that with some orange pekoe tea that sells for $4 a pound. So that's my orange pekoe. And they want to end up with 100 pounds of the new blend. So I'm going to put 100 here because that's going to be my mixture, and I want to end up with 100 pounds total. Now, the selling price for the blend is to be $5.50. So I'm putting that there because that's what matches the column of what makes one different from the other. And so the question is, how much of each kind should there be? Well, one of the things that's helpful in these kind of problems is to know, first of all, that these two amounts have to add to this one. And if you have a total amount and you want to split it into two parts that are not necessarily equal, you call one of those X and the other one 100 minus X. Now let's see how that works. Suppose that you wanted to end up with 100 and this amount was to be 30. Well, to figure out how much was left over, you would subtract that 30 from the 100. Or if this amount was to be 80, then to find the amount that was left over, you would subtract that 80 from there to get 20. So that's why this works. And this is a useful tool anytime you know a total and you need to separate it into two parts. Now, it doesn't matter which one's X and which one's 100 minus X, but I'm just going to do it this way. And what we want to do is to multiply straight across. So we're going to multiply 6 times X and 4 times 100 minus X and 550, so I'm just going to put 5.5 times 100. And in this case, what that represents is money. The amount of money per pound times the number of pounds equals the money earned from the Earl Grey tea. The same thing from the orange pekoe. The price per pound multiplied by the number of pounds gives you the total money. So the money from the Earl Grey, which was 6X, plus the money from the orange pekoe, which is 4 times 100 minus X, should be equivalent to the money from the mixture. So that's 5.5 times 100. And once you get to this point, you should be home free, because now all we have to do is just solve the equation. So I'm going to begin by clearing up some stuff, and I'm going to start with multiplying 5.5 times 100 and getting 550. And then I'm going to distribute this 4 and get 4 times 100 and 4 times negative x. Then I'll clean this up. 6x minus 4x is 2x. I can subtract 400 from both sides, and I get 2x equals 150. Then I'll divide by 2 and get x is 75. So I need to see, what does that represent? Well, I go back up to my chart, and x was the amount that I used for the Earl Grey. So my answer would be to use 75 pounds of Earl Grey and then the remainder part would be 100 minus x, so 100 minus 75 would be 25 pounds of the orange pekoe. And notice that those two together make up the 100 pounds that I was looking for. Alright, now we're going to go next to problem number 25. And in this one, we're making some mixed nuts. Let's see what we have going on here. They normally sell cashews, so this is going to be my cashews, for $9 a pound. And they sell almonds for $4.50 a pound. So now they want almonds and nuts. So in order to sell 60 pounds of almonds, the manager decided to mix that 60 pounds with some of the cashews and sell it for $7.75 for the mixture. And we don't know how much cashews that they're going to put in there. That's the question for this problem. How much cashew should be used? Well, if you take X pounds, why is this not staying focused? Sorry. Let's see if I can do better. Okay, now it's back in focus. I'm sorry. If you add X pounds to 60 pounds, you have X plus 60, because they just add together. So now, why is it not focusing? What's it focusing on? Sorry, I don't know what's going on with my technology. Alright, now I'm going to multiply straight across. So 9 times X, 450, which is 4.5 times 60, and 7.75 times X plus 60. If you use this little chart like I'm suggesting, to get this third column, you always just multiply straight across. And then to make your equation, you take 1, add 2, and make it equal to 3. That's the way you're going to form an equation each time. So 9x plus 4.5 times 60 is going to equal 7.75 times X plus 60. Alright, so now I need to do some cleanup work to make my equation look better. So I'm going to multiply 4.5 times 60 and get 270. And I'm going to multiply 7.75 times X. And I'm going to multiply 7.75 times 60 and get 465. Alright, so there's nothing I can do to this side and nothing I can do to this side. So I'm ready to subtract 7.75x from both sides. And when I do 9 minus 7.75, I get 1.25x. I copy my 270. That zeroes out, and I copy my 465. Now I'm going to subtract the 270. And 465 minus the 270 is 195. So to solve for x, then I need to divide by 1.25. And when I do that, I get 156. Well, what does that represent in my chart? What was x? I come back up here and see that x was the amount of cashews. And so that's the answer to my question. I need to use 156 pounds of cashews. So we have to look at what the question is in the problem. What are they asking us to find? And you see the last sentence was how many pounds of cashews should be mixed. So you have to look to see what kind of question you're trying to answer. Alright, now we're going to go to number 26. And in this one we're mixing candy. And the store has boxes of candy that contain caramels and creams. So here's my caramel and here's my creams. And I'm going to mix them together. And the box of mixtures sells for $12.50 and holds 30 pieces of candy. If the caramels cost 25 cents to produce, okay, I'm sorry. As I look over this problem, this one is more complicated than the ones that we're going to be working with because it's dealing with revenue and profit. So we'll just scratch that one. Pretend like you're in class and I just made a mistake. So we're going to just scratch out that one and we're going to go on over to number 41. Alright, this time we're mixing water and antifreeze. So I'm going to mix together some water and some antifreeze. This is going to be pure antifreeze to get my mixture of antifreeze. And so the question is, how much water, that tells me this is my unknown amount, should be mixed with 1 gallon of pure antifreeze, so this is 1 gallon, to obtain a solution that is 60% antifreeze. So I want this to be 60%. Alright, so this has some logical reasoning in it that you won't find written in the problem. So what makes it different is how much antifreeze is in it. Well, you know, hopefully, that water has no antifreeze in it at all. So that'll be 0. And then that pure antifreeze means it's 100%. Okay. So what we're going to do to these percents is convert them to decimals. Well, when you convert a percent to a decimal, you move the decimal point 2 places. So this just becomes a 1, like 1.00. And then you move this one 2 places, this becomes 0.6. Alright, so if I have X gallons that I'm mixing with 1 gallon, I have X plus 1 gallons altogether. These two have to add to get this one every time. So I'm going to multiply straight across and have 0 times X and 1 times 1 and 0.6 times X plus 1. Why will this thing not stay in focus? Alright, so remember 1 plus 2 equals 3. So 0 times X plus 1 times 1 equals 0.6 times X plus 1. 0 times anything is 0. 1 times 1 is 1. 0.6 times X is 0.6X. 0.6 times 1 is 0.6. 0 plus 1 is 1. So I'm going to subtract 0.6, which I should be saying 6/10 to be mathematically correct. And 1 minus 6/10 is 4/10. Now, when you take 0.4 and divide by 0.6, normally I would say to you, leave it as a fraction. But typically, when it's a word problem, we use a decimal more, but this one is different. When you divide by 0.6, you get either 4/6, which is 2/3, or if you do it on the calculator, you get 0.6 repeating. So it would have to know what do they expect, and 0.6 repeating is more often written as 2/3. So in this case, they want you to choose the 2/3. If it's I guess the rule of thumb is this a way that you might actually measure something? Would you actually measure something as 2/3 of a gallon as opposed to 0.6 of a gallon? So this would probably be the more common measurement. So we've got 2/3 equals X, and what did X represent? The amount of water, and that's what the question was asking us, was how much water. So our answer is 2/3 of a gallon of water. All right. Let's go down then to number 43. This one is about salt, and we're going to take some water out because we're going to evaporate water. So how much water must be evaporated from 32 ounces of a 4% solution to make a 6% solution? So what we have is a solution that's currently 4%, and we have 32 ounces of it. We're going to take out some water. We don't know how much. And when we take out that water, it's going to make the salt solution stronger. So now it's going to be a 6%. Well, water hopefully has no salt in it, so that's going to be a 0. And 32, remember we're taking it out this time, so that's 32 minus X, because we're going to evaporate the water. So we're going to convert this to a decimal, so that'll be 0.04 times 32, and then 0 times x, and convert this to a decimal, 0.06 times 32 minus x. And again, what makes this one different is that because we're using the evaporation process, we're actually removing something. So that's why this is minus here. So 0.04 times 32, and I'm going to subtract 0 times x, and that's going to give me 0.06 times 32 minus x. Okay, so 0.04 times 32, that's 1.28. 0 times x is just 0. 0.06 times 32 is 1.92. And 0.06 times x is 0.06x. Alright, 128 minus 0 is just 128. So I need to get x isolated, so I'm going to subtract the 192. And I'm going to get negative 0.64. Alright, so now when I divide, my negative 0.64 divided by negative 0.06, it comes out 10.6 repeating. So you could do it like that, 10.6. Remember, we just talked about that 0.6 repeating is 2/3. You could also call it 10 2/3. And this was measured in ounces. That's how much water I need to evaporate. Now, the back of the book is not consistent. In problem number 41, they used a fraction for 2/3. In number 43, they rounded this off since it was 10.66666. They rounded it off to 10.67. So you're just going to have to look at the directions that are given in My Math Lab to see, do they want you to express the answer as a fraction, or do they want you to express the answer as a decimal? And it should give you that information. Now, that's the end of the mixture problems. So we're going to also work on some distance problems for this, but I'm going to split this assignment into 2 parts. So at this point then, you should be ready to work on the assignment for this mixture part. You may have noticed in the first assignment for this week, the new assignment, 10.5 I guess it was, that I'm putting the videos in with the assignment so that you don't have to go multiple places to look for things. So I'm going to do that with this one as well. So I'll be back later with the video on how to do distance problems.